In this question we have a coil in a magnetic field and we have to find the EMF between 2 points on the coil. Let's start by examining the magnetic flux through the area of the coil before it starts turning. Magnetic flux depends on the number of magnetic field lines that pass through or penetrate the area of the coil. So imagine that we are looking at the coil from sideways. We can see that in this position no magnetic field lines penetrate the area of the coil, and as a result magnetic flux is equal to 0. Let's examine the magnetic flux once the coil has been rotated by 90 degrees. What we see here is that the area of the coil is parallel to the magnetic field lines. So again, no field lines are penetrating the area of the coil, which means that magnetic flux here is also equal to 0. To make this absolutely clear, I will draw a magnetic field and a coil below where the magnetic field lines penetrate the area of the coil, creating a non-zero magnetic flux through the coil. So if the direction of the magnetic field is into the page, as I have drawn here, and the coil is in this position, the field lines penetrate or cut through the area of the coil, creating a non-zero magnetic flux. However, this is not the case in our question, so magnetic flux is equal to 0 before the coil starts turning, and it remains 0 throughout the motion of the coil. Since the magnetic flux remains 0, clearly the change in magnetic flux is equal to 0. Looking at this equation from subtopic 11.1, where epsilon is the induced EMF, n is the number of turns in the coil, delta phi is the change in magnetic flux, and delta t is change in time, we can conclude that since the change in flux is equal to 0, the induced EMF in the coil will be 0, which will mean that the EMF between points x and y is also 0, giving us answer A.